The next section of Chapter 6 is about logarithms. We're going to evaluate and simplify logs today. So the reason why we want logs is for solving equations when we have a specific type of equation. So for example, in this first equation, we know that division is the opposite of multiplication. So in order to get x by itself, we do the opposite of multiplying by 2, and we divide both sides by 2. And that tells us that x is equal to 4. In this next example, we have x squared is equal to 8. And last chapter, we spent some time saying, well, the opposite of squared is the square root. And we said, well, we have two different answers, but that's okay. We just get x is equal to plus or minus the square root of 8, which is the same thing as the square root of 4 times 2, which is the same thing as the square root of 2 times, wrote that backwards, it's 2 times the square root of 2. But with this kind of problem, where the x is in the exponent, we don't yet have a way to undo raising something to the x power. So that's our motivation for why we want logs. We're going to leave this problem right now and talk about it later. You might be able to figure out what x is in this particular situation, but you might not be able to in other situations. We'll come back to it. So I'm going to teach you something called the triangle of power. The triangle of power helps you visualize logs. The problem is that mathematically, we have 3 very different notations for describing the relationship between 2, 3, and 8 here. One way we can describe it is we can say 2 to the 3rd power. We know that's equal to 8. This new notation is going to be log base 2 of 8 is looking for the missing exponent. And then last chapter we were working on cube root of 8. We're looking for the missing base. So when we look at the triangle of power, the top of the triangle is always the exponent, the bottom left is always the base, and the bottom right is always the answer. So if we do this problem, we're really saying 3 squared equals 9. So we'd put a 9 in this corner. If we do this problem, we're saying something to the 4th is equal to 16. So mathematically what we're saying is, what's the 4th root of 16? And since 2 times itself 4 times gives us 16, that answer is 2. I recommend that you pause the video and try these triangle problems. See if you can figure out what the missing number is, and then restart the video and we'll talk again. But pause now, fill in the missing numbers, and then come back. So this is what I got for the missing numbers, and mathematically what this is saying is 5 to the 3rd power is equal to 125, so that's what we're looking for. This one is saying 2 to the negative 3rd power. Because it's a negative exponent, it brings it to the other part of the fraction, so that becomes 1/8. And then this one is saying, what's the 4th root of 81? And that's 3. These 3 are all talking about this new relationship. This is saying log base 10 of, oh, I wrote a 3 there. I thought it was 1,000, I guess. This is a 2. Log base 10 of 100 is 2. That's the exponent of 10 that gives us 100. And this one we would write as log base 5 of 125, 1/25 is negative 2. The negative exponent turns it into a fraction. And this one is saying log base 2 of 32 is going to be 5. With logs, what we're looking for is a missing exponent. All right, so we're going to practice going back and forth between log form and exponential form. And I always think that triangle is helpful. So if I put the 3 here and the 4 here and the 81 here, what that means is log base 3 of 81 is equal to that exponent. Okay, and then if I put this into the triangle, I have 10, I have 1,000, and I have 3. So in exponential form, that would be 10 to the third equals 1,000. Try these two if you haven't already. Give those a shot. So pause the video and come back after you've tried those. They're my answers to these ones. This is log base 7 of 343 is equal to 3. Logs are always equal to the exponent. And then in exponential form, that would be 4 squared equals 16. All right. So I recommend using a triangle for these problems. If I want to evaluate a log, I would just sketch out a triangle and say, well, the base is 5, the answer is 125. I'm looking for the missing exponent, so that would be 3. For this one, the base is 3, the answer is 0, and I'm looking for the missing exponent. But actually, this is a trick question because there is no number that raises 3 to a power and gives you 0. Remember, 3 to the x looks like this, and that doesn't ever exactly reach 0. So this one has no solution because there's no answer to 3 to the x is equal to 0. And then this one, our base is 4, our answer is 1/16, so we're looking for the exponent, that's going to be -2. And then this one, if you draw a triangle, I feel like it's totally obvious. The base is 2, the answer is 2 to the 8th. What's the exponent? Well, the exponent would be 8. All right, just some language. If we use a base 10 log, it's called the common log, and we usually don't write the base 10. Just like with exponents, if we have an exponent of 1, we usually don't write it. And if we have a coefficient of 1, we don't usually write it. If we do a square root, we don't usually write the 2 inside as an index. So common logs, we don't usually write the base. It's because we have 10 fingers. We're just used to being 10 being normal. The other kind of special log is called the natural log. The natural log is base e, and we don't usually write base e, but this would be equal to log base e of x. We just don't usually write it that way. We usually write natural log. If you're wondering why it's ln and not nl for natural log, it's because it comes from the French. So in French, you would say the word for log before you would say the word for natural. So these questions are calculator questions because there is a button on your calculator that says log, and there's also a button on your calculator that says ln. So if I type log of 900 on my calculator, I can get a decimal answer. So 2.9542. And then this one I don't need a calculator for because the base is e, the answer is e, so this would be 1. But I could also type that onto my calculator using the ln button on my calculator. Go ahead and pause and try these ones out, and then you can check your answers in a moment. But pause the video now so you can check your work. Okay, my calculator gave me an error when I tried to do natural log of a negative number. And the reason for that is if you remember all these exponential graphs, they're all up in the first and second quadrant. So we don't have any y coordinates that are negative. So we can't do a natural log of a negative number, just like we can't do a log of a 0. The other ones I just typed directly onto my calculator. What you might notice is that logs are a way of making really big numbers into smaller numbers. So if you want to compare the magnitude of numbers, logs are a nice way to do that. 900 is 3 digits long. All numbers that are 3 digits long have a log of between 2 and 3. All numbers in the, what did I do? Yeah, so log of 900 and log of 321 are about the same size because they have the same number of digits. And logs of decimals are going to give you negative numbers. All right. The next skill we have is solving equations using logs. And so when I'm solving equations, I'm going to think about changing the base, or writing it in exponential form, sorry. So the base is 10, the exponent is x minus 1, and the answer is 25. So if I write that as a log, it would be log base 10. We don't usually write the 10 when it's a log base 10 of 25 equals x minus 1. If I want to get x by itself, I would add 1 to both sides. And then I'd grab my calculator and just type log 25 plus 1. And I get x is equal to, I did natural log, so my answer was way too big, 2.398 to the nearest thousandth. If I wanted to check that answer, I could do 10 to the 1.398 because I subtract 1. That's not going to give me the exact answer of 25 because I rounded, but it gives me 25.003, so it's pretty good. All right, so this is a log equation, but I can rewrite it as an exponential. The base is e because it's ln. The exponent is 4 because that's the answer with a log. And so then if I write that exponentially, it'd be e to the 4th equals 2x plus 3. So I'd subtract 3. And then I'd divide by 2. And if you type this onto your calculator, just make sure you're grouping that e to the 4th minus 3 because you want to divide that whole answer by 2. So on my calculator, to get to the e to the x button, it is the second natural log button on my calculator. And so I get 25.799. And I could check that by checking what the natural log of 2 times that plus 3 is. It's going to be about 4. So I encourage you to try these ones and then unpause after you have given them a shot. Pause now. All right, so these are my solutions to those problems. I started by rewriting them in the other form, and then I used my calculator for the second one. I didn't need my calculator for the first one because I was doing 10 to the second power. So the summary here is logs are a way of bringing exponents down, of working with the exponent and figuring out what the exponent is. We have 2 important logs that we can use our calculator for, and those are log base 10, which is the common log, and log base e, which is the natural log. All right, good luck today. Thank you.